Now we would like to write equation of the tangent line at the point 342 for the curve of intersection of these two cylinders. And first notice 3 and 4. 3 square plus 4 square is 25. So we are fine here. And then 4 square plus 2 square is 20. So either of them are, each one of them is okay. So if you look at this curve, then this gives us that we can write x as 5 cosine t and y as 5 sine t, right? And then when we take y equals 5 sine t in this equation, what we get is sine square t, or actually we should say y square means 25 sine square t plus z square equals 20. So that will mean that our z square will be 20 minus 25 sine square t, right? All right, and we are going to look at the portion in which it is positive. We'll take that up in a moment. Now note that we are confined in the vicinity of this point, 342, all right? So we will be near z equals 2. So z square would be positive, and at the same time, what we will do is that we shall take the positive square root of this quantity as the parameterization of, for z. So our curve is going to be, what our curve is going to be, or equation of our curve will be 5 cosine t, right? Then 5 sine t, okay? And then we have square root of this. And what we have to determine is this, which should not be too hard in this, in this textbook case. That is, we want to find the value of t for which we will have x, y, and z take on these values, right? So if we say took 5 cosine t as 3, then cosine t is 3 over 5, right? And what will sine of t be? So now 3, 4, 5, they're Pythagorean triples. So this gives us sine of t would be 4 over 5, and if we put 4 over 5 here, this will become 2, and 4 over 5 here, this becomes 4. So things are good. So what we would have is that our t at the point where we have to write the equation of the tangent line, or an equation of the tangent line, will correspond to cosine inverse 3 over 5. Okay. So now remember, our objective is this, that is, we would like to find an equation of the tangent line to the graph of this curve, okay, which is what, r t equals this parametric vector, okay, all right, at this value of t. So you know this, that the tangent line is along what? The derivative of r with respect to t. So the first thing to do would be, we will go ahead and calculate our dr dt. All right, and that is going to be, well, here it is negative 5 sine t, right? Here it is 5 cosine t, sorry about that, cosine t. And now we will use the chain rule. So derivative of a square root is going to be what? 1 over 2, right? The square root of the quantity, and times what? Times the derivative of the quantity, right? And what is the derivative of this quantity? If we differentiate, the derivative of 20 is 0, and this would be negative 50 sine t, sorry, cosine t, right? Now we have to evaluate this at what? At t equals cosine inverse 3 over 5, which means again what? That cosine is 3 over 5, and sine will be what? Sine will be 4 over 5, right? So let's just write it down for sake of convenience. So cosine t is 3 over, not that, and the sine t is 4 over 5. Okay, and now we can go ahead and calculate this value at t equals cosine inverse 3 over 5, right? So here we go, and we will say that we are at cosine inverse, okay, sorry, 3 over 5. All right, okay, good. So that is going to be, okay, I think we don't have to have the font sizes that large. So here if we take sine t as 4 over 5, then this quantity is negative 4. Cosine is 3 over 5, so that will be plain and simple how much? 3. Sine is 4 over 5, so this quantity would be how much? 20 minus 25 times 16 over 25. That will just become square root of 4. That is, this would be times 2 here, and in here what will happen? We have sine t as 4 over 5, cosine t as 3 over 5, so those two 5s are going to reduce this to 2, and then we have 2 times 4 times 3 just from the numerators, okay, and then the vector is going to be finally the vector is negative 4, 3. These twos cancel. I think that just becomes what? Negative 6, right? Okay, so this is negative 6. Now we would like to find the tangent line at what was the point? 3, 4, 2, and the line is parallel to this vector. So what an equation of the line will be, we can write that as a parametric equation, right? And that parametric equation would be, excuse me, negative, no, sorry, 3 minus 4t, right? And then we have 3 minus 4t, then 4 plus 3t. Yeah, so this is the vector along the tangent line, right? And then we have 2 minus 6t. So this will be an equation. Let's go ahead and just for the just for sake of verifying it and practicing MATLAB 2020A, because I'm switching from MuPad that they dropped in MATLAB 2020A, so that's a practice for me too. So let's just go ahead and graph it in MATLAB just to verify our answer. Okay, so now we are done with the question. So we want to just graph these all. So what we would do is that we shall graph this line which is tangent to this curve, and just to be sure that we will just go ahead and graph these as well, because now that we have we know how to do those, right? And then y square plus z square is 20. Okay, so one thing, let's just go ahead and first see how much this value is, so that we know what kind of window will contain the value. So that value is about 0.927. So for this we will give the t value as from 0 to 2, and in this one you can see 3 corresponds to t equals 0, 4 corresponds to t equals 0. This correspond here 2 would be I need a 2, so that will also be at t equals 0. So what we can do is that we can just take it at -1 to 1 for rt. All right, so let's just go to the graphing window. Okay, and what I would do at this time is that already took a break and did this, that wrote the commands. Okay, so I'll just copy and paste them. I could have written them in like live script, but right now let's just let's just be content with this. So here we go. Okay, so we got this, right? So this will do the plot for us, right? Okay, and we will change the color, sorry, figure properties. Let's change the color because we need a prominent color later on. What would look prominent? Let's make it magenta. We never made anything magenta yet, right? So then we are going to say hold on. Okay, and then we will go ahead and bring our tangent line. Okay, all right, and I just shrank it to 0.5 to -0.5 to 0.5, and let's see how it looks. Yeah, that doesn't look too bad. So here is the curve and this is your tangent line, and let's just go ahead and plot the cylinders also. It doesn't cost us much. Okay, so if we do that, because I wrote that as well, and where are those guys? I can just go ahead and type it. fx y z equals x squared plus y squared minus 25, and then sorry, gx y z equals y square plus z square minus 20. All right, and then what I would do is I would just go ahead and get this thing here, f implicit. So what I did was I just took the window very close to the window that we had there. Now one moment, we graph those two guys, and let's hold on because they gave me the version 2020B. In that one I don't have to keep holding on as I go, but here I have to, I think I have to. Okay, so all right, so let's see how does it look now. That doesn't look too bad or doesn't look too good either, but you can just take your time to fix it if you want. That is, you can see that the line is going through intersection, and the orange line is tangent to the purple line, right? Okay, good. All right.